Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer E-Club's Ask the Cook. We're here to talk about polymers and polymer application. We help you answer the question, what do you need to know to add polymer skills to your career? When volumes are lower and part finishes could be secondary processes, an interesting process to consider for making parts is called reaction injection molding, called RIM in the trade. It differs from injection molding in that the material that goes into the process is reactive. That is, it's a liquid because its component parts are fed to the process. And then the curing process goes on and you get a solid, which you then eject out at the end. So it's not a melt process and then solidify. It is a liquefy, mix and react, and then eject a completed cured solid. So this process can be pulled, the part can be pulled out of the mold by hand in some very low volume processes and trimmed by hand. And I've also seen daisy wheel and daisy chain processes with up to 40 or 50 or 60 molds that can be filled and the thing goes around a track and then you have an extraction station where the part is kicked out. This process really kind of lends itself to lower volumes than injection molding. So if you have a part that you need less than 100,000 copies of per year, and it's a large part perhaps, or it has the possibility of some secondary finishing like decoration, you may consider this process. And basically the way it works is you fill this cavity with a low molecular weight and low viscosity mixture. It's created with a mix head. So in the sense it's like an injection molding machine which creates a molten mix, except this one is not created so much by heat. It's that the materials themselves are liquids or near liquids at room temperature. So you mix them together, you push it into the mold. The viscosities are relatively low, so the pressures are not incredibly high, and as a result the machine doesn't need a fancy and giant and heavy clamp, and the mold itself doesn't have to be that sophisticated, although some heating does often make the mold behave better. So a thin-walled aluminum mold might be a very appropriate thing for this process. And so you can look around the world and you can see a lot of housings for medical equipment that are made this way. And it's not because medical equipment requires any special properties as much as it is the fact that the machines are very expensive and therefore not made in huge volumes. And so the economics of the RIM process fit better than injection molding for those kinds of parts. Knowing how RIM can help you be economical and make large parts even at less than 100,000 parts a year, well, that's working knowledge. Just what you get when you share here with this community at Polymer E-Club, Ask the Cook. Don't forget to subscribe, like, turn on notifications, and even share if you appreciate the content. You can follow a link in the description to learn more about Polymer E-Club and how you can get involved in the community. I'm Todd Cook for Polymer E-Club's Ask the Cook. Thanks again for watching.